Hello, I'd like to give you a quick example of using a math channel in Waveforms with the Analog Discovery 2. So I've just set up a simple circuit. It's not one that you actually use in the experiments, but it's similar and just an example of doing a math channel. So I have a 100 ohm resistor, a 1N914 diode set in here. And what I've done is I connected on one end, I've connected wave gen 1, right? And this should say what 1 plus, not plus 1, but channel 1 positive terminal here. Across the resistor, I have channel 1, so I have 1 plus, 1 minus across the resistor. So channel 1 is going to give me the voltage across the resistor. Channel 2, I have across the diode in here. And don't forget the ground on this. So it's a simple circuit connected. And now if I go ahead and go to waveforms. Okay, so in waveforms, if you look at the bottom signal down here, I have set up wave gen 1 triangle wave. I just chose the triangle wave, 1 kilohertz. And if you look, it's set for 5 volt amplitude. So it's going from -5 to +5, which is the pretty much the limit of what you can get out of the wave gen. But needless to say, I just have a triangle wave in there. If I look up here, again, remember channel 1, the orange, is the voltage across the 100 ohm resistor, right? So if I look at that, we're going to use that to calculate the current through the LED, through the, not LED, through the diode. So if I know the voltage across, I can divide by 100 ohms, I can get the current. Right? The blue channel is the voltage on the diode, and the diodes, when we reverse bias them, and we'll talk about this more in the semester, we don't get any current flow. So we just get a voltage across the diode. You notice the current's 0. When we forward bias them, you notice we sort of have a limit as to how much voltage we can get across. So we talked about that a little bit in the experiment. But I can see the current's changing as I change the voltage. And again, I got a triangle wave for the input voltage on that. So I can take this voltage and say, okay, I want to know the current. So I'm going to add a channel. And it's going to be custom. And so this shot pops up and hey, I can do power. I don't care about power. Just do that. But if I look down here, channel 1 and channel 2 are available to me, right? So I'm going to use channel 1, and I'm just going to say divide. What's it doing here? Divide by 100. Okay, channel 1 divided by 100 ohms. That's going to give me my current flow. And you notice it's nice in here, you can change units. In amps, right? Voltage divided by resistance gives me current in amps. I say okay. And so I have this thing sitting here. And if you look now, I have a channel down here. And it's set for microamps per division. Not sure why I got it to that, but if I go back up, and let me just go to, say, 50 milliamps per division. Okay. So over here, you can see the scales giving me my math channel in the units I want. And okay, 50, I could probably see a bit more if I go to 20 milliamps per division, right? And if I go to 10 milliamps per division, if I think about taking my input voltage, divide it by 100, and then change it to a scale in milliamps, that I actually get 10 milliamps per volt. And so these scales now, where I have volts here and 10 milliamps here, they fall on top of each other. And again, I can turn off the math channel real quick. You see channel 1 sitting there, turn the math channel back on, there it is on top of each other. So this red curve now, as it says, is the current flow in the resistor, which is the current flow through the diode too, of course, in milliamps. And we're saying, if we look at experiment 3, we want to cap this at probably 25 milliamps or less, because you notice this is flat. That's the most the Analog Discovery 2 can give us. It's doing as hard as it can, and we've saturated it. So this is also part of the reason we say you always look at the input signal and the output, because if you assume that the wave generator looked like this down here, you'd be wrong. It is actually being saturated. It cannot, if I turn this off, that's the positive voltage, that's the wave gen. So I didn't actually give you the input signal because I was trying to do current and voltage here. But in any case, it's there. So you can do a math channel relatively simple with the add channels and custom And then you have things there. And the fact that C1 and C2 are the actual signals that you have available. Okay. So that's just a quick example of adding channels.